Hello everybody, this is going to be a quick video that introduces the Legged Races Studio, so let's just get right into it. For starters, we have this question, every semester we have this question, including the first semester where people ask, can you go over a little bit more interesting or more real-world example than iterative averaging. So I'm not sure if this is a real-world computing example, but it's certainly a real-world physical analogy. So I want you to imagine that all of us are paired up for a three-legged race. So in two different incantations of this, one is we have one n+1 legged race. So imagine that there's 50 of us in the class. This would be like the 51-legged race. We're all bound together and we all kind of have to make progress as we're only as fast as the slowest person. And in the other version of this, I want you to imagine n/2 three-legged races. So there's 50 of us in class. This would be 25 three-legged races. And in this one, the work is the same. There's sort of like the same sort of task can be done in parallel, but there's just less coordination that's required, less waiting around for everybody that happens in this version. So further, we're going to talk about like sort of where the ones over here are fast starters and then run out of gas, so they get slower at the end. And these ones, guys, these participants over here are going to be slow to start, but they have a good big kick. They can they finish strong, and these guys are in the middle. Each one of these participants right here, each column, excuse me, is an individual participant, and I've color coded them by team. So let's go over to Eclipse. This is the Legged Race Visualization app. You can, of course, find that by Command or Control Shift T and just start Legged Viz, sort of narrow it down. And if I run this guy, you can see we're going to start off with the program as it goes. There's these are the 16 participants. I've sort of grouped them in their three-legged race team. So this is the two people who are participants who are on the orange team, if you will. When we run the other, there's 4 races over here. This one is the warm-up, the sequential one, but then there's a normal parallel one, a normal one that's the phased version of this. So these ones will look very similar. And so these are the two, if this is 16, 17-legged races. So where there's one 17-legged race going on in each one. And this one is going to be the 8 three-legged races. So if I run the sequential one, you can see it's sort of everyone's taking step 0 together. This will take quite a long time, so I'm just going to cancel it. But you can imagine once you're done with step 0, we move on and everybody starts taking the next step. That one's, we'll build that as a warm-up. The parallel version, everybody's taking their steps together, if you will, but everyone has to wait for the previous step to complete before, so step 9 has to wait for step 8 to finich before it goes. You can see that took about 9 seconds to complete. This one is very similar. It just has lower overhead. So this sort of flips the loops inside out. So the sequential is on one side and the parallel's on the other, and it uses a phaser to complete it. You can see it does it about the same time, which makes sense because this is a visualization that's trying to slow things down, and the phaser is not a big part of the overhead. But you can see those behave very similarly. And finally, there's sort of this for all phase point to point where everybody's only waiting on their partner. And this takes less time. You can take 6 seconds instead of almost 9 seconds. And you can see these guys blaze ahead, and they are slow in the end. These ones over here on the right are a little slower to start, but they don't. They pick it up in the end and sort of go quickly. This is very different from for all phase, where they all have the same characteristics, but everybody's always waiting on the slowest person. Okay. So with that, let's talk really quickly about this. So what are the loops? And I'd like everyone to pause in between each one of these and answer them. So what are the loops? Okay, and we're back. So the 2 loops are, one is for the steps and one is for the participants, right? That's the amount of work that has to happen. All these participants need to take all the steps required to finish each race, right? So which one is the outer loop? Is it going to be the steps or is it going to be the participants? And that's conceptually outer loop if you sort of ignore the phaser part, like which is the one that's for sequential or the normal parallel one, which would be outer. All right, and we're back. And hopefully a lot of you came up with the idea of like, we'll answer both of these together. What's the outer and what's the parallel loop? So the outer loop, I would argue, is the steps, right? So everyone has to take step 0 before they move on to step 1, right? The parallel part is each one of the participants can do their step in parallel if they want, right? And what are the dependencies? Well, they're different for each of these cases. For this one, every single person is waiting on the previous step to complete for all of the participants, right? There's a bonus dependency if you look at this guy running, right? If I run this, well, this is going to be one of these for all ones. Each one has a dependency on its previous step. So every participant has a dependency with their previous round step, whether you run the for all legged race, for all phased, or whatever. For all point-to-point also has that, but then they're dependent on their neighbor, right? And these, the sort of normal parallel ones that aren't point-to-point depend on all of the other participants finishing their previous loop. And so with that, I will sort of just introduce you to the Legged Race Studio. The sequential one, we're going to do a video on that, but there's also an optional warm-up where you build the sequential version. Then you're going to build a for all. That's just a normal parallel one, which has a sequential loop on the outside and a parallel one on the inside. The phased one uses a phaser so that it has lower overhead, and you can flip them inside out so that the parallel loop's on the outside and the sequential's on the inside. And then this point-to-point version is the variety where, let me just go right here. The point-to-point one is where, all right, I'm only depending on my neighbor, okay? All the other ones depend on all of the participants to finish the previous step in order to move on. And so with that, I'll say good luck and have fun with the studio.